All right, so now I'd like to show, not tell you, how the composable CDP works using a demo. So I'm going to give you what I call my inside-out demo, with the emphasis really being on how the composable data applications work in Snowflake, not as much on the applications themselves in the Simon product. And so to do that, I'm just going to select a few representative data apps to walk you through, since going into detail on all of them is going to be beyond the scope of the webinar. But let's start by taking a look at our sandbox account in Snowflake. This contains all of our demo accounts as well as integration testing accounts. And what I'm going to do is drill into the database that backs our demo. So in particular, what you'll notice here is that we've organized this database into various schema. There is one which essentially acts as the gateway to all the rest of your data in your cloud data warehouse for input. And then there's what we call the data routing schema, where Simon is actually creating and centralizing data on your behalf. So Simon's writing into this particular schema as it collects data that is unique to it. Then there are application-specific schemas, which we're going to drill into in a lot more detail. And then lastly, there is a write schema where Simon can produce data and write it back out from the internal operations of all these various data applications. Some of these apps are relatively stateless, as for example, segmentation. The constructs that you'll see inside of that are just views. And so we'll go into more detail in terms of the no-code builder that's used to compose these views, ranging to apps like identity, which is a much more stateful process that we'll cover in a little bit more detail in a moment. But this is effectively just the back end of Simon's data applications. And the focus is really much more on managing objects inside of the cloud data warehouse and less on explicit ETL into downstream systems. So let's kick it off by taking a look at the user interface for identity. Like I said earlier, identity is core for adapting your business model into your CDP contact profile. And what it really does is it gathers together identifier associations from across your organization, like user profiles, loyalty programs, lead lists, point of sale records, and combines all those things together to create a stable identifier that's really what's used to identify individuals in the downstream data applications. So as I click through here, you can see that I'm running through what the form that's exposed to an end user to actually configure that identity resolution process. And they're given all manner of options in terms of defining the rules which allow rows and input data sets to be combined into one particular identity, as well as survivorship rules, which really define like which identifiers become the primary or enabled identifiers for a given identity when merges and identities occur. So the way that this is going to be accessible in your downstream data applications is essentially through identifier mappings that are both useful to map identifiers from within your organization into downstream channel identifiers and vice versa. And then, like I mentioned earlier, the way that an identity model is actually deployed into the account is via a versioned system that allows you to deeply QA the identity model before it's actually deployed into your downstream data applications. So now I'm going to jump back into the actual back end of identity and call out the outputs to begin with. So really the central output is going to be this resolved identities table. You can see there's the stable identifier of your Simon ID that was created by the identity resolution process. And then there's a number of aggregations that are applied to the various identifiers, which effectively represent your survivorship rules. In addition to this, you're given a audit table, which effectively annotates all of the inbound raw records with the Simon ID that they're allocated to. So it gives you the ability to determine what inputs have gone into building a particular identity. And then lastly, backing up all the way to the input, The identity source union is where you take all those various data sets that we selected via the no-code interface and combine them together into a sparse union before where they're fed into a deterministic connected components algorithm to really define that stable identifier for each merged identity. So like I say, the core algorithm here is deterministic connected components. And in this particular case, identity needs to be deterministic for marketing and support use cases. It's less critical that it be deterministic for advertising or analytical purposes. But the way that these two things are combined together in Simon is that our entity resolution offering is probabilistic and our identity resolution offering is deterministic. And we're looking ahead to the future to even decouple entity resolution from identity resolution and offer it more broadly as a generic data modeling application. Awesome. So next up I want to jump into is segmentation. So this is the no-code form that a marketer is presented with when defining and divvying up contacts for more targeted messaging and analytical purposes. So as you can see here, any attribute of the logical contact profile is available for segmentation or anything that can be joined onto the profile. So in this case, we're using a predictive input around second purchase propensity that's a property of the profile, as well as business rules that are also properties of the profile, and they're encoded in a separate segment. And then we're joining that to behavioral event data. In this case, the way that we're defining a disengaged but likely to submit a second purchase user as one that's not engaging with email events recently. So now jumping to what that looks like inside of our application, this manifests as a view. And so you can see here that we have purchase propensity, we have membership in that separate segment, and then we have aggregation that occurs over the event table of the email events. And so this relatively elaborate SQL query was generated for a non-technical user using that no-code interface that we saw earlier. The key point here is just really that we enable a non-technical business owner both to generate these views and to QA them. And that QA process is done through metrics computed over the top of the audiences, both over time and instantaneously, so they can just verify that they've actually defined the correct audience that they're looking for. All right, and then lastly, I want to take a peek into activation. So activation is really where we're allowing a marketer, advertiser, or support rep to publish data out of the cloud data warehouse and into downstream channels. And then once it's been published, to keep it in sync as data changes over time. So I have two illustrations of that. One, in this particular case, we're keeping a list defined by our high LTV customer segment in sync in a downstream Klaviyo channel. And you can see the way that this is synced over time. And then two is utilizing syncing of traits. And this really allows us to not only export contact properties from the cloud data warehouse, but again, as they change over time, keep them in sync with the downstream Klaviyo user profile as the data actually updates. So jumping back into the back end of this particular application, we can see that for some constructs like lists, these can be just relatively simple views, and they're easy to keep in sync, just utilizing instantaneous membership as well as personalizations that are joined into that membership here. But for the trait syncing that I showed earlier, we actually create a stream over a transient table, which we've built to actually monitor the data for changes over time. And so this is a way of just effectively streaming those changes downstream into the event-driven update endpoint of the user profile. So in both of these cases, though, what can be done is that an organization can actually just subscribe to these data constructs, and then they can observe the data that's actually powering the downstream activation from their cloud data warehouse.